evaluate the limit if it exists. So we have a fraction 1 over a plus h square minus 1 over a square all over h. If we plug in h equals 0 directly, so it's going to be 1 over a plus 0, a square minus 1 over a square of 0 on the top as 0. So 0 over 0. That means if we graph this function at h equals 0, we have a hole on the graph. That means limit is still exists. Okay, there is a chance limit exists, and we want to find that limit now. We need to somehow get rid of this h, zero making factor, h and h from top and bottom. The bottom is already simplified. Now we need to combine these two fractions on the top. So we need to take common denominator. We can multiply second fraction by the bottom of first and do the same thing here, a square over a square, and combine these two fractions. Or we can multiply top and bottom, the whole thing, by the common denominator, which is, okay, this came out to be 0 over 0, so we are doing the next step, which is limit h going to 0 of h on the bottom 1 over a plus h square minus 1 over a square. Now I would like to multiply by the common denominator, which is this a plus h quantity square times a square. This is one block, another block, and same thing on the bottom. So we can multiply by this. Now how does this help? So let me write in the next step, limit h approaches to 0 of, on the bottom we have to write all because there was no issue in the first place. So h times a plus h square, a square. On the top, this fraction times this common denominator, then this fraction times this common denominator. Okay, so when we multiply this first fraction by this, what are we going to get? 1 over a plus h square, and now we are multiplying by this a plus h square, a square, when that means this over 1, this to cancel. So 1 times a square, just a square left on the top, minus, when we multiply this with this common denominator, a square cancel. Okay, just for the second part, and 1 times a plus h square, just a plus h quantity square left over on the top. Okay, now we need to simplify the top. Here we got a plus h square, so that is, what is a plus h square? This is not simply a square plus h square. So this one is in fact a plus h times a plus h. So we need to multiply. So FOIL, this is a square plus ah plus ha plus a square, sorry, h square. Ah and ha are same, so we can combine these two. So this comes out to be a square plus ah, two copies of ah plus h square. So that goes here, and -1, there is no sign, means -1. So we need to distribute -1 from outside. So I'm going to write that in next step here. So this is limit h going to 0. There is no issue on the bottom. H a plus h square, a square. On the top we got a square here. Now this is -1 times this product, so I'm gonna multiply here. So distribute -1, so negative a square, negative 2ah, negative h square. Okay, so a plus h square multiply, then there's a negative, minus sign is -1, we need to distribute -1. Now we are here, combine the like terms. In this case, plus a square minus a square cancel. Okay, so remember we are trying to cancel h from top and bottom. So bottom h, a plus h is square, a square. On the top we got two terms, and both of these two terms have h. So let me factor h out. That leaves negative 2a minus h square, 1h out, this h. Now once we factor h out, then we can cancel. Okay, because h times everything, that's why we can cancel. Now that leaves the h from the bottom is gone, so the zero making factor is gone. Now we can simply plug in h equals 0. So I'm going to do that. So negative 2a minus 0. Since I'm using h equals 0, I don't have to write limit anymore. Over a plus 0 squared. That's a squared times a squared. And this is in fact negative 2a on the top over a square, a to the fourth on the bottom. So this negative can be pulled to the front. One copy of a cancel with 4 copies, so 3 copies left on the bottom. So the final answer is negative 2 over a cubed. Okay, so the limit of this expression is just negative 2 over a cube. Final.